So, this video is to show how to balance a chemical equation. We're starting off with unbalanced equation. We have ethanol reacting with oxygen to form carbon dioxide and water. The next step is to list out each element that is present in order of increasing frequency. Now what this means is the fact that carbon appears in only two things means we're going to list that first. 2 is the minimum that anything can appear. Next, we can do hydrogen. Hydrogen also appears in only 2 substances. But the fact that oxygen appears in 1, 2, 3, 4 substances is why we have to list and therefore balance oxygen last. Next, we indicate how many of each element there is on each side of the equation, total. On the left, we have 1, 2 carbons. On the right, we only have 1. On the left, we have 5, 6 hydrogens. On the right, we have 2. On the left, we have 1 plus 2 oxygens for 3. And on the right, we have 3 oxygens as well. Now, using only coefficients, we try to balance each element starting at the top and working our way down. So I'm going to start off by putting a 2 next to the carbon dioxide. That way we will have 2 carbons on the right as well as on the left. However, notice how we also, since there's oxygen there, we also must change now the total oxygens on the right. 2 times 2 is 5, plus 1 more is 6. Excuse me. 2 times 2 is 4, plus 1 more is 5. Got ahead of myself. Now we do the same thing for hydrogen. We have 6 and we have 2. So we put a 3 there. 3 times 2 gives us 6 hydrogens, but again, it changes how many oxygens there are on the right. Again, we have to retotal it. 2 times 2 is 4, plus 3 more gives us 7. Now, on the left, we have a choice. We can put a number here to give us more oxygens, or we can put a number here to give us more oxygens. Since the carbon and hydrogen are already balanced, and by putting a coefficient there that would throw the carbon and hydrogen out of balance, we are going to want to avoid that if at all possible. So instead, we're going to try and put a coefficient here. Now the question is, what number times 2 plus 1 will give us the 7 that we need on the left? And of course the answer is 3. By putting a 3 there, 3 times 2 is 6, plus 1 gives us 7. Everything is now balanced, and the equation is balanced. And now I'd like to show you a couple more samples that you're going to be coming across, things that might be a little bit challenging and perhaps give you guys a shortcut or two. So in this example, we have iron sulfate, specifically iron 3 sulfate, reacting with potassium hydroxide to produce potassium sulfate and iron 3 hydroxide. Now, when you're looking at this, your first impulse would be, oh man, I got to separate out the iron, the sulfur, the oxygen, the potassium, and hydrogen. And you can separate them all out by their individual elements. However, when you're dealing with a problem like this that has polyatomic ions, you can also keep the polyatomic ions together if they appear in the same format on both sides. So if you notice, SO4, sulfate, appears both on the reactant side and on the product side as SO4. Same thing with hydroxide. It's both here and over here, which means that if we wanted to, we can keep them together. Now, believe it or not, keeping them together makes this a much easier problem than if you were to separate them. Okay, so let me show you guys this. First of all, I want to show it to you as we keep them separate, all right, just to give you an idea about it. All right, so if we were to separate these, we see that iron is in two places, so we can start off with iron. Sulfur is in two places, then we can do sulfur. Oxygen's in four places, so we want to do that last. We have potassium, and then hydrogen, and then oxygen. So iron, we have 2, and over here, iron is 1. All right. Sulfur on the left, because of this 3, the 3 distributes inside, and that means we have 3 sulfurs. Whereas on the right, we only have 1 sulfur. That 4 only applies to the oxygen. Potassiums, we have 1 potassium on the left. On the right, we have 2 potassiums because of that subscript. Hydrogens on the left, we have only 1. On the right, that 3 distributes in, and we have 3. Oxygens, we have 3 times 4 is 12, plus 1 over here, so we have 13 oxygens on the left. On the right, we have 3 oxygens here plus 4 oxygens here, which means that we have 7. So we just start going through and balancing. Iron is 2 here, but 1 there. So we're going to try and put a 2 in front of the iron 3 hydroxide. That changes the iron to a 2, but now we have to recount both oxygen and hydrogen. So we have for hydrogen, 2 times 3 is 6. So now we have 6 hydrogens. Oxygens, 2 times 3 is 6, plus these 4 there. That brings us to 10. Now sulfur, we have 3. We need to have 3 sulfurs on the right, so 3 there will give us the 3 sulfurs. But that also changes both potassium and oxygen. So the potassium is 3 times 2 is 6 potassiums. And then sulfur, sulfur's already done. And then oxygen, 3 times 4 is 12, plus 2 times 3. So that gives us a total of 18. Now on this side, we have 6 potassiums on the right. We want to have 6 potassiums on the left. So we go and put a 6 in front of the potassium hydroxide. That makes that a 6. Hydrogen becomes a 6. And oxygen is 6 plus 4 times 3 is 12, gives us the 18. All right, so as you can see, there is a bit of mathematics, especially with the oxygen. Now, if we go and try the same problem again, but this time keeping together the polyatomic ions. All right, so we have iron. Now sulfate, SO4. All right, SO4 we're going to keep together. Potassium, and then hydroxide, OH. So on the left, we have 2 irons. On the right, 1. Sulfate, we have 3. No multiplication necessary, just whatever the number is on the outside of the parentheses. So we have 3 there. There's no parentheses here, so we only have 1 sulfate on the right. Potassium, we have 1 on the left. On the right, we have 2. Hydroxides, we have 1 on the left since there's no parentheses, but on the right, we have 3. So we just go through like we normally do. We have a 2 and a 1. We put a 2 there, gives us 2 irons. 2 times 3 gives us 6 hydroxides. Sulfates, 3 and 1. We're going to put a 3 in front of the potassium sulfate. That will give us 3 SO4s, but that will also give us 6 potassiums. And then we just finish off by going 6 in front of the potassium hydroxide, make 6 of that, and 6 hydroxides. And now it's balanced. And as you can see, a lot less multiplication, and we end up with exactly the same final answer. Now, when you're doing these, you are allowed to do either way, whichever way makes more sense to you. I just wanted to show you this shortcut way. They go faster and it makes the math a little bit easier in my opinion. Now, the last one I want to show you is a sample of a combustion reaction. Now, remember, combustion reactions are whenever you have a hydrocarbon, any compound with both carbon and hydrogen. It could also have oxygen or other things. But if it has carbon and hydrogen, and it reacts with oxygen gas, O2, it will always produce carbon dioxide and water vapor. So this is a combustion reaction. And these can be a little bit tricky because of the fact that we may have to scale up, as you will see. So we're just going to list them out in order of frequency. Carbon's found in only 2 things. Hydrogen's found in only 2 things. But oxygen's found in 3 species. So we put that last. On the left, we have 6 carbons, 14 hydrogens, and oxygens, we have 2. On the right, we have 1 carbon, 2 hydrogens, and 3 oxygens. So we start off easily enough. We put a 6 in front of the carbon dioxide, makes that a 6. Oxygen, 6 times 2 plus 1 is 13. Now hydrogens, we have 14 and 2. So by putting a 7 in front of the water, 7 times 2 gives us 14. But oxygens, we have 12 here plus 7 gives us 19. Now this is where you have the difficulty, because if you notice, we only have oxygen here, and because of its O2, oxygens on the left have to be a power of 2, a multiple of 2, as it were. Excuse me. So there's no number that we can put here, no whole number at least that we can put here, that will give us 19 on the left. So this is what you can do. Since there's no oxygen any other way, and there's no way of getting 19 otherwise, temporarily, even though you're not supposed to do this and leave it like that, we're going to put a fraction. So what number times 2 equals 19? Well, 19 divided by 2 is 9.5. So if I put a 9.5, that gives me the 19. Now, it may look balanced down here, but we cannot keep a fraction, a decimal, as a coefficient. So what can we do to get rid of that 0.5 and yet maintain the same ratio of 1 to 9.5 to 6 to 7? What you do is you just basically look at each one and you double each of the coefficients. So this becomes 2. All right. 9.5 becomes 19. 6 we erase to become 12. And 7 we erase to become 14. Now we double check. Since we doubled everything, there's 12, 28, and then that's 38. On the right, we have 12. 14 times 2 is 28. And then 12 times 2 is 24. Plus 14 is 38. And we end up with a balanced chemical equation and whole numbers. And remember, when balancing, you always have to end up with the lowest whole number ratio of coefficients. If I were like, for example, to double it again and have like 4 and 38 and 24 and 28 here, that would technically not be correct because it's not the lowest whole number ratio. All right, so I hope you have found this interesting. Well, at the very least, helpful. And if you have more questions, please come to tutorial.